So let's futz around with ZooKeeper a bit. I've already sparked up my Hortonworks sandbox here, like I always do. And it just runs automatically. So ZooKeeper is configured to automatically start up with your sandbox here. So there's nothing we need to do to start it or install it. It's just there already because so many systems that Hortonworks installs depend on ZooKeeper. So let's just log into it. Maria_dev. And let's SU up to root because I don't want to deal with permissions issues. All right, so let's first go to where ZooKeeper lives. That actually is under cd/user/http/current/zookeeper-client. And under here, if you do an ls, you'll see there's a bin folder. Let's go in there. And in here, among other things, is the ZooKeeper CLI, zkcli.sh. That's the command line interface for ZooKeeper. Obviously, in the real system, you would be coding against the Java or the C++ interfaces for ZooKeeper instead. But if you just want to connect to ZooKeeper and mess around with it, you can do that too. So we can kind of see what's going on there under the hood. So let's go ahead and connect to it. /zkcli.sh. And we are connected to ZooKeeper. So from here, we can do some basic operations to see what's going on. For example, we can say ls/ to see what's on the root level. So remember, ZooKeeper just looks like a little file system, but the secret is that it's a highly consistent file system that can be replicated across several ZooKeeper servers. Now in our little desktop sandbox system here, there's only one ZooKeeper instance, but if there were more than one, this would all be magically replicated and we would all agree on, or hopefully all agree on what's where. So you can see here that we have existing subdirectories for different systems like Storm and Drill and HBase Unsecure. Solar's in there as well. So a lot of the things that come pre-installed with Hortonworks already have ZooKeeper little areas here to play with. Let's go ahead and pretend that we're setting up a new system of our own. So imagine, if you will, that we have a system that has a single master and every client needs to agree on who that master is. So imagine my application is running on a node that wants to become the master for this system. It might issue a command like this. So we can say create-e, and that means it's going to be an ephemeral Z node. So automatically, if this session goes away, this node will automatically be deleted. So that way, as long as this process is running that's talking to ZooKeeper that created this node, then ZooKeeper will report it back as the master. But as soon as this node goes away, as soon as I disconnect, this master node that I'm about to create will also go away, and that will give other nodes an opportunity to make themselves the new master. So create-e, we just need to give it a name, a path, if you will, to the file that we want to store this in, or the Z node more specifically. So let's create a Z node called testmaster. And now you can store whatever you want in there. Basically any binary data is valid to put inside a Z node, but we'll put in some text. Imagine that it's just a address for some web server that is the master. In this case, 127.0.0.1:2223. You can store anything you want in there, really. And it created it successfully because there wasn't already an existing test master that had a lock with somebody else. So let's see what happens here. Let's, for example, say get/testmaster, and we can say that we can see what's in there. So you can see it came back with 127.0.0.1:2223. And if I were any other client on this system that said get/testmaster, it would get the same result. So imagine clients in a system that need to know who the master is. They can just say get/testmaster and get its answer back. Now, let's say that this node goes away. So let's just quit out of the ZooKeeper command line interface. And to ZooKeeper, that's going to look like my node just died. It disconnected and maybe someone shut it down. So now my master is no longer available. So ZooKeeper has automatically deleted the testmaster Z node as a result because I specified it was ephemeral. So if we log back into ZooKeeper, let's do a ls/ again, and you can see that my testmaster Z node is no longer there. It does not exist because it was automatically deleted when I disconnected because I was the person who wrote it. So in this situation, let's imagine that I'm another system that wants to log on to this system. It's trying to find out who the master is. Maybe I can say get/testmaster to find out who the master is. It's going to say, uh-oh, that node doesn't exist. You don't have a master. So my application at this point might say, okay, well, if I don't have a master, maybe I should be the master. I will just nominate myself as the master. So I can say create-e/testmaster, and maybe it'll put in, some information about itself, what process it's running on. And now that's going to be the new test master. So now when I say get/testmaster, that's what comes back. Now let's say that I try to create another one. The good thing about ZooKeeper is that it won't let you do that. So the node already exists for testmaster, and it says, someone else already has the master node locked. It belongs to 127.0.1.2225. If you're trying to make another master of yourself, you can't do that because ZooKeeper ensures that there can be only one and only one in this situation. So imagine what might be happening in a real-world failure here. Let's say a master node set itself up by creating its test master, or whatever you want to call it, Z node, and that master goes down. So because it was ephemeral, that test master node will disappear, and the other clients will try to figure out who the master is, and it will get back a message that says there isn't one. So all those other clients can try at the same time if they want to create that test master node on their own and become the new master, but ZooKeeper will ensure that only one of those clients is actually successful in writing to that new test master Z node. So in that way, only one master node exists at a time, and it ensures that the master is actually responsive because of the ephemeral nature of that node. All right, so that's how it works. Now, because it's ephemeral, I don't need to delete it. All I need to do is quit out of ZooKeeper CLI, and I've cleaned myself up. That test master node will be gone again. So there's sort of a hands-on example of how ZooKeeper might work. Again, it's very contrived. We're running on a single machine here instead of a real cluster, and we're using the command line interface instead of actually programming against ZooKeeper through the ZooKeeper client for Java. But conceptually, that's how it works, and you can see that it's a real thing that we're actually working with here. So there's ZooKeeper for you. Let's move on and exit out of this shell and go on to the next subject.